Okay, so in section 3.4, we're talking about rational functions and graphing rational functions. Let's see if we can get this actually showing up here. And part of that's going to be looking for asymptotes. And we'll have three different types of asymptotes: vertical, horizontal, and then slant asymptotes, or I think our book calls them oblique asymptotes. And so to find those oblique asymptotes, we're going to need to use long division of polynomials. And so I'm going to review that first off. If I can get everything open here. Okay, so here's an example of that. So what are the quotient and remainder when 5x to the fourth minus 2x squared is divided by, let's see, x cubed minus x squared plus 1. Okay, so when we're dividing by something other than just a linear factor, then we're not going to be able to use that synthetic division that was nice. We'll actually have to use long division. And so the way that's going to work, I'm taking 5x to the fourth minus 2x squared, and let's write that out without skipping any powers of x, right? And so since we're not seeing x to the third power, this is going to be plus 0 x to the third power, right? And then minus 2x squared. And then we don't have an x term, so that'll be plus 0x. And then we don't have a constant term, so that'll be plus 0. And now we're taking this and we're dividing it by x cubed minus x squared plus 1. Okay, so I'm going to look at the leading term here, the highest power term, and the highest power term here, and I need to ask myself, what should I multiply x cubed by to get 5x to the fourth? Okay, so I'm going to say I multiply that by 5x. And when I multiply it now, I need to actually go back, multiply everything by 5x, and put them underneath the corresponding powers of x here. So I'm going to get 5x to the fourth. And then I had minus x squared. So that's going to be minus 5x cubed when I multiply 5x by the second term, right? And then I need to multiply 5x by 1. And so that's going to show up under this term. And then what I want to do is take all of that and subtract it from the original polynomial. And so I have 5x to the fourth minus 5x to the fourth. That part cancels out. And then I have 0 minus negative 5x cubed. So I'll end up with just positive 5x cubed. And then what do I have left? I have minus 2x squared. Nothing's being subtracted from that. And then I have minus 5x. Okay. So now what I need to do is I'm going to do the same process now and ask myself, okay, what do I need to multiply the leading term, x cubed, by to get 5x cubed? So that would be just 5, right? So I'm going to have 5x plus 5. That's going to be my quotient. Now I need to figure out what the remainder is. I'm going to take 5, multiply through. So I'm going to get 5x cubed minus 5x squared. And then plus, let's see, I should put this over here, plus 5 on the end. And so now again, I'm going to take this, subtract everything, and I'll end up with what? I'm going to have the leading term cancels, and I'm going to have minus 2 minus negative 5, so 3x squared minus 5x, and then minus 5. Okay, so that tells me I can take 5x to the 4th minus 2x squared, and I could rewrite it as the quotient, the quotient times what I divided by, plus my remainder. So what we have here is going to be the remainder. Okay, so in your homework, you're going to have questions that ask you, what is the quotient and remainder, right? So this part right here, what we got when we divided, is the quotient. What you have left over at the end, that is your remainder. Okay, so we're going to need this sort of calculation when we're working on finding asymptotes of rational functions. All right, so your first homework problem is just going to have you review that, and then you'll move into actually graphing rational expressions. The first one, let's look at the graph of just f of x equals 1 over x. So this is graphing rational functions. So we have f of x equals 1 over x. Okay, for this one, if we're going to graph a rational function, there's a few things we need to look for. We need to look for vertical asymptotes, horizontal asymptotes, and in some cases, we'll have these oblique asymptotes, is what your homework calls them. Okay, so to find vertical asymptotes, we're looking for places where this function is undefined, right? So where would this be undefined? Okay, yeah, so when x is equal to 0, and then we'll get a vertical asymptote if the numerator is not also 0 at that point, right? So if x is 0, you get a 0 in the denominator, but the numerator is 1, right? So as we approach 0 from either side, that means that we're going to have numbers that are 1 divided by numbers getting smaller and smaller. Those are going to be, these numbers going to 0 means that the overall function is going to blow up, right? If you take 1 divided by 0.0001, for example, you start to get really large numbers. Okay, so then the question, though, is on each side of this asymptote, is my function going to go down along that asymptote or up along that asymptote? And so for that, I need to look at, as I approach this asymptote from the left, that means I have values of x that are less than 0, right? And so x is going to be negative as I approach from this side. That means I have a positive over a negative, so I'm going to have negative values, right? And so the only possibility then, since my function has to either go down or up along this asymptote, it's going to have to go down since the values are negative. Does that make sense, everybody? And what's going to happen from the right? If I approach this asymptote from this side, from the right side, what's going to happen? Your x values are going to be positive on the right. So then you're going to have 1 over positive numbers. Those are going to be still positive, right? And so which way does it have to go? Along that asymptote, it has to head up towards positive infinity, right? Okay, so we have a vertical asymptote in this case. At x equals 0. And then to finish graphing this, we should also look for horizontal asymptotes. So for this, we need to think about what happens to the function as x gets really large. What should the function be approaching here?
0.
It's going to be approaching 0. And so it's going to look something like this. Does our function ever cross the x-axis? No, we don't have any way to take 1 over x. If we set that equal to 0, you're not going to have any solution to that, right? If you multiply both sides by x, you'd be saying 1 equals 0, right? Which is not true. You wouldn't have a solution. As we go to the left, we're going to have the same sort of thing going on, right? As the x values get really large in the negative direction, it's going to smash down to 0. Okay, so we have a horizontal asymptote at y equals 0. Okay, so that's the graph of 1 over x. It's kind of a standard graph that you can shift around, right? And so part of the homework, you might be recognizing that a graph is a shifted version of this one. Another one that we should look at would be, let's say, if we had f of x equals 1 over x squared. What about vertical asymptotes? Okay, still going to be a vertical asymptote at x equals 0. If you plug in 0, you're getting 1 over 0. So as x approaches 0, you're going to have 1 over values going to 0. That causes an asymptote. And then we just need to decide, as we come in from the right and from the left, which direction those are going along the asymptote. So as I come in from the right, I have values of x that are positive. So when I take them and square them, still positive, right? And so I must be going up along that asymptote. What about from the left?
It's going to be doing the same thing.
Right, good. Since x is squared, even when you have negative x values, you're going to get positive in the denominator. So this time, you're going to get them going the same direction. And then similarly to the last one, as x gets really large, this overall function is going to go to 0, and so we'll have a horizontal asymptote here. Okay, again, it never crosses the x-axis because you can't ever have 1 divided by something equal to 0, right? If you have a fraction equal to 0, the only way that can be true is if the numerator is equal to 0. Okay, so for vertical asymptotes, on this one you would say you have one at x equals 0. For horizontal asymptotes, you would say y equals 0. Okay, so these are two standard graphs that you'll see in your homework, probably shifted around. Okay. What if you're asked to find the domain of a more complicated rational function? So this one just says find the domain, and you have some function. You have 2x over or times x minus 5 divided by 4x squared minus 27x minus 7. So for a rational function, where are you going to have problems? Where is it not going to be defined? Okay, so yeah, so when that denominator equals 0, then our function is going to be undefined at points where this is true. So at this point, this then just becomes this is a quadratic, right? So you solve that in whatever way you like to solve quadratics. Here where we don't have 1 in front of x squared, I'd probably just jump to the quadratic formula. Right, and then those are going to be the two values once you compute those, right? So those will be the two values you're not allowed to have. And so you'll have your domain is all values of x except for those two, right? Okay. Yes?
When that is supposed to be a 4. I think he said
2a, yeah, so you're right. I combined and didn't at the same time. Good catch. All right. Okay, so that's how you would find the domain, and then what's going to happen is, that's all this question asks, but in general what's going to happen is if you plug this in, this value of x, whatever you get, or these two values, if you don't get 0 in the numerator as well, you're going to know you have a vertical asymptote at those points, right? Okay, let's walk through some of the questions here are going to give you a graph, and you have to identify asymptotes from the graph. And so, for example, if you're given, this is question 4, by the way. They could give you a graph. In this case, it looks like this. Gives you vertical dotted lines at -3 and 3. And then at y equals minus 3, gives you another one that's horizontal, right? And then it shows a picture like this. Something like that. So, and then it asks you to find the domain and range. So, which two x values are we not allowed to use here? 3 and negative 3, those two asymptotes. So, the way that your homework is going to ask you to fill this in would be x such that x is not equal to negative 3 or 3. What about the range? Okay.
X or Y cannot equal -3.
Right, exactly. So you would write that as, let me make sure I'm writing this in the form that they want. Okay, so what we need to do is, and in fact, I drew my function slightly off from theirs. It actually looked, you can see from their picture, it actually looks like something like this. It shows you exactly where that y goes through the axis. And so in that case, what is my range going to look like? I know, yeah, negative 3 is not included. But if I write in interval notation, what are my intervals going to be? Negative infinity to negative 3. And I'm not including negative 3. And then where does my other interval start based on the graph? Yeah, negative 2 to infinity. The what, sorry?
Square bracket on
Oh yeah, we're including negative 2. Thanks. Okay. So that's domain and range. Then it asks for intercepts. Well, it just says the intercepts. So that, I guess, would mean x and y intercepts. Right? And so what are we right here? What are our two x intercepts? Yeah, so minus 2 and 2, I guess, based on the graph. And then okay, it's going to split them up. Ask for your x-intercepts, in which case I think our homework only asks for the number, like the x values, right? And then y-intercepts, you would have, what, it was a height of negative 2 where it crosses the y-axis. And then it asks for horizontal asymptotes. Okay, so that's just going to be, yeah, this line, y equals negative 3. And then for vertical asymptotes, you're going to have two of them, right? At what, negative 3 and x equals 3. Let me see how it wants you to actually put those in, though. Yeah, it just gives you x equals, so we'll put negative 3 and 3. Okay, now it's also going to ask for oblique asymptotes. These are also called slant asymptotes. Now, those are only going to occur in a very specific case. And on graphs, you'll see them as an asymptote that is, not vertical or horizontal. So it'll be, like a line that is slanted, right? And so here we don't see any of those. Okay, but in special cases where you have a rational expression where the power in the numerator is just one higher than the power in the denominator, like the degree is one higher, that's when you're going to get slant asymptotes. And then we're going to have to use that long division to figure out what they are. Okay, so that's coming up, but we don't see any of them here. You're going to have some that look like this. So we had our graph of y equals like 1 over x or 1 over x squared. And you're going to have functions where you need to transform those graphs, right? And so here we're supposed to graph, this time they give us negative 1 over x squared minus 6x plus 9. So what I'm going to do is try to rewrite this as a shifted graph of either 1 over x or 1 over x squared. What could we do with the denominator here?
Put it into the square.
Do what, sorry?
Put it into the square.
Oh, okay. Yeah, so this is going to be what squared? We're going to have x minus 3 squared when we factor it. Good. And I just pulled the minus sign clear out in front. Okay, so what does this minus 3 do? What does it do to shift our graph of 1 over x squared?
To the right.
Moves it to the right 3. And what does this minus sign on the outside do? Yeah, flips it upside down, right? And so when we're trying to find the graph out of their list, we would want to shift that original graph of 1 over x squared, which if we remind ourselves, that one looks like this, right? We're shifting that graph to the right 3 and then reflecting it over the x-axis. Okay, so we're going to have our vertical asymptote here at x equals 3, and then instead of going up along that asymptote, our function is going to go down along that. So then you'll be looking for the graph of that. Now, this one will also go on to ask you, what are the vertical asymptotes? What are the horizontal asymptotes? Are there any oblique asymptotes? And all of that, okay? How are we feeling so far? Other than super awake and happy that it's 8:30 in the morning, right? The cases that we've looked at so far, the highest power in the numerator is less than the denominator, less than the power in the denominator. And then in those cases, you get these horizontal asymptotes at a height of 0, right? But what happens if the power in the numerator and denominator are the same? So here's an example of that. We have 4x squared minus 7 over x squared. Okay, we can find vertical asymptotes the same way that we've done before, right? Where would we have a vertical asymptote in this case?
X equals 0.
Yep, at x equals 0, because that will make the denominator 0, but not the numerator, right? And so we will have this vertical asymptote there at x equals 0. Okay, now they're also going to ask us to give a little bit more information here. So what about horizontal asymptotes? How are we going to find that? So I guess the question is, what happens as x gets really large, right? The idea is that as x gets really large, this number and this number are going to get really large kind of at a similar rate, right? Whereas this minus 7 is going to matter less and less as these numbers get bigger, right? And so to find the horizontal asymptote, what we could do here is just look at what happens if we ignore all the powers of x that are lower than the highest one. So we just look at 4x squared over x squared. That means as x gets really large, right, then this function is just going to behave really closely to this one, because that minus 7 is going to matter hardly at all when these numbers are huge, right? And so that means we're going to be settling on a height of 4, right, for our horizontal asymptote. So you're going to have a horizontal asymptote at, sorry, not x equals 4, at y equals 4. So to find horizontal asymptotes, if the powers on the top and bottom are the same, you really just look at that highest order term on both top and bottom and see what you get when you divide. In other words, it's just going to be the quotient of the coefficients of those highest powers. Okay, so then we end up with that. And if we're going to graph this, we'll also need to know what's happening along those asymptotes. Are my values above or below, right? As x gets really close to 0, right? So for this vertical asymptote, as x gets really close to 0, this is going to get really close to 0. And then I have a negative number. So then this overall number is going to be negative. You see that on the numerator. And then in the denominator, you're always going to have a positive number that's going towards 0. So we have a negative over a positive from each direction. And so we know that we're going to have, from each direction, we'll be headed down, along this asymptote. Okay, so then our graph is going to look something like that, and you would want to, find that one in your list of graphs that they give you. It's going to ask you where all the asymptotes are, and then it will ask you if there are any oblique asymptotes. And like I said, you only get oblique asymptotes if the power in the numerator is 1 larger than the power in the denominator, the highest power. Okay, so let's see if we can find somewhere there are oblique asymptotes. Here's one. So oblique asymptotes occur when the degree or the highest power of the numerator is 1 more than the degree of the denominator. And then to find them, what we need to do is do long division on the rational function. So you have, for example, r of x equals x cubed minus 1 over x squared plus 3x minus 4. So here, the degree of the numerator is 1 more than the degree of the denominator, so we know we're going to have a slant asymptote. And we can perform long division, right? So x cubed plus 0x squared plus 0x minus 1 divided by divided by x squared plus 3x minus 4. Okay, so we're going to follow the process that we did on the example in the beginning. We need to multiply x squared by x to get x cubed. And then multiply all the way through, so we'll get x cubed. And then we'll get plus 3x squared minus 4x. Right, and then we need to subtract. So we're going to get, what, minus 3x squared minus negative, so plus 4x. And then bring down that minus 1. Now do the same thing. I need to take x squared and multiply it by negative 3 to get this leading term. So I'll get a minus 3 here. Okay, and then I'll have negative 3x squared minus 9x plus 12. And so when I subtract, I'm going to get 4 plus 9, so 13x. And then minus 13. Okay, so what that means actually is I could take my function r of x, which was x cubed minus 1 over x squared plus 3x minus 4, and I could write that as, when I do this division, I'm going to have x minus 3 plus the remainder, which is 13x minus 13. I couldn't actually divide there, so I'm just going to keep it as being divided by 3x, or x squared plus 3x minus 4. Okay, so you can split it up as the quotient plus the remainder divided by whatever you were dividing by. But you do this because what's going on is as x gets really large, right, what's happening to this part? Sorry, go ahead.
A bit smaller.
Right, it's going to get closer to 0 because the power in the denominator is larger than the power in the numerator. So this part actually goes to 0 as x gets really large, which means as x gets really large, it's going to behave like this function, x minus 3, which is a slanted line, right? And so what that tells us is we have an oblique asymptote. And that oblique asymptote is going to be the line y equals x minus 3. So as x gets very large, it's going to get really close, our graph will get really close to this line. Okay, when you have an oblique asymptote, you do not have a horizontal asymptote. It's one or the other, right? So you're going to say there's no horizontal asymptote. For vertical asymptote here, what would I need to do on my original function? Yeah, set that denominator equal to 0. So let's see, x squared plus 3x minus 4 equal to 0. And so that's x plus 4, x minus 1 equals 0. So we're going to have vertical asymptotes at negative 4 and 1. And well, okay, so yeah, okay, so, and then let's see, what else is it going to ask? Okay, actually we need to double check, right, that when you plug those in, they don't make the numerator 0 as well. So here, the the 1 actually, when you plug that in, you get a 0 in the denominator and the numerator, right? And so we don't actually get a vertical asymptote there. But -4, you'll get a 0 in the denominator, but not the numerator. And so our vertical asymptote is only going to be at -4. And I think that's all. Yeah, so we've covered all the different things that show up in this section. So the main ideas were horizontal asymptotes. If the degree of the denominator is larger than the degree of the numerator, you get horizontal asymptotes at 0. If the degrees are the same, then you need to look at the coefficients on the highest power of x, right, to figure out what that horizontal asymptote is going to be. And if the power on the top is 1 higher than the power on the bottom, that's where you get these oblique asymptotes instead of horizontal. So that about wraps it up for that section. Does anybody have questions they wanted to ask from, I forgot to ask at the beginning today, if anybody had questions from the homework they wanted to bring up? We good? Okay. Get working on this. Bring questions tomorrow if you have them, and we will keep moving forward.